Welcome to True Projects. In this video, we are going to explain about a project titled Spam Transfer Model for SMS Spam Detection. The project's introduction acknowledged the widespread use of short message service as a popular communication tool and the persistent issue of spam, which involves the delivery of irrelevant and unwanted messages through the mobile network. The main goal of the project is to explore the effectiveness of the modified transformer model in detecting the SMS spam messages. The increased relevance of the mobile phones and mobile networks has made individuals more susceptible to receiving the spam messages. The introduction emphasized the negative impact of SMS spam, which includes privacy breaches, financial loss, and potential security threats. While traditional approaches like machine learning classifiers and rule-based methods have been used to detect the SMS spam, the limitations in the term of accuracy and scalability require the investigation of the alternative solutions. Hence, the project proposes a modified transformer model, a neural network architecture known for its success in natural language processing tasks. The project centers on addressing the challenge of SMS spam detection, a significant issue in mobile communication. To tackle this problem, we introduce a customized transfer model specifically designed for detecting the SMS spam messages. The primary goal of the project is to comprehensively assess the performance of our proposed model using the existing machine learning classifiers and the state-of-art SMS spam detection methods. We aim to demonstrate that our proposed model outperforms the current approaches in terms of accuracy and efficiency in detecting the SMS spam. Additionally, the project explores the potential future direction to further enhance our proposed model. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. The hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the steps involved in it. The first step is importing the libraries. In this step, essential libraries and packages for data analysis and modeling are brought. These libraries provide various functionalities such as data manipulation, visualization, and implementation of the various machine learning algorithms, and commonly used libraries are NumPy, Pandas, Matplotlib, Seaborn, TensorFlow, and Keras 2. And the second step is importing the dataset. Two datasets containing the relevant data for the analysis are loaded into the project. These datasets are in the format of CSV, and loading the dataset allows for the data exploration and preparation for further analysis. And the third step is dropping the columns which are not important. Once the datasets are imported, irrelevant and redundant columns that do not contribute to the analysis or modeling are dropped. Removing such columns help in reducing the unnecessary computation and streamlining the data for better performance. And the fourth step is checking for the null values. The data sets are thoroughly examined to identify any missing or null values in it. Missing data can lead to the errors during the analysis, and addressing them is crucial for accurate results. Strategies for handling the missing values, including the computations of replacing the missing values with estimated ones or removing the rows of columns for the missing data. And the fifth step is data visualization using the word cloud. Word clouds are created as a visual representation of the most common words in the test data. They provide a quick insight into the predominant terms and themes present in the data set. Word cloud aid in the understanding and underlying the pattern and topic within the testable data. And the sixth step is test pre-processing. For the test data, certain pre-processing steps are applied to prepare it for analysis and modeling. In this process, two key test pre-processing steps are performed. The first one is converting the string to the lowercase. All the test data is converted to the lowercase to ensure the uniformity in analysis, as a capitalization may result in duplications. And the second one is remove all the non-ASCII characters. Non-ASCII characters such as of special symbols or emojis are removed to ensure the clean and standardized test for further analysis. And the seventh one is label encoding of the target variable. The target variable, which typically represents the outcome or the class to be predicted, is encoded into the numerical format, where machine learning algorithms often require the numerical representation of the target variable, and the label encoding converts the categorical label into the numeric values. And the eighth step is applying the algorithms for the two data sets. First one is logistic regression. Here, logistic regression is a linear regression model used for the binary classification problem. It predicts the probability of instance belonging to the certain class. It works by fitting a linear equation to the input features and applying a logic function to the output, which maps the prediction to the probability value between 0 and 1, and in case it's spam or not spam. Its probability is greater than the specific threshold, the instance is classified as one class, otherwise it is classified as the other class. And the second one is naive Bayes. Naive Bayes is a probabilistic model based on the Bayes theorem and the assumption of the independence among the features. It is commonly used for the test classification tasks such as spam detection, sentiment analysis, and document categorization. The model calculates the conditional probability of a class given the features and select the class with the highest probability as the prediction. Despite its simplistic assumptions, naive Bayes often performs well on the test classification task and computationally efficient. And the third one is random forest classifier. It is an ensemble method that combines the multiple decision trees to improve the prediction accuracy and reduce the overfitting. Each decision tree in the ensemble is trained on a random subset of the data and the features. During the prediction, the final result is obtained by averaging the predictions of all the individual decision trees. And the fourth one is SPM. SPM is a supervised learning algorithm used for binary classification tasks. It aims to find the optimal hyperplane that best separates the data points of the different classes. The distance between the hyperplane and the closest data point from each class is maximized, allowing for the better generalization to unseen data. And the fifth one is LSTM, that is long short-term memory. It is a recurrent neural network well suited for sequential data analysis. It addresses the vanishing gradient problem of traditional RNN, allowing it to capture the long-range dependencies and the sequential data, and having the memory cells and gates that control the flow of information, enabling the model to retain the relevant information over long periods. And the sixth one is CNN LSTM. CNN LSTM is a hybrid model that combines the strength of convolutional neural network and LSTMs. Here, in a CNN LSTM, the CNN layer is used to extract the meaningful feature from the input data, which are then fed into the LSTM layer to capture the temporal dependencies. This model is widely used in the tasks that involve both the image and the sequential data, such as video analysis, action recognition, and image captioning. And the ninth one is training the model. The selected machine learning and the deep learning models are trained on the pre-processed dataset. During the training process, the model learns the pattern and the relationship in the data to make the accurate prediction. And the 10th step is user gives the input. Using the Flask framework, the user provides the input data for prediction. The input data is in the form of text or of numerical value that are relevant to that message. And the 11th step is the given input is pre-processed for prediction. The user provided input is pre-processed to ensure it matches the format used for training model. Similar, the pre-processing step is applied to the user as of the given input. And the 12th one is trained model is used for prediction. The trained machine learning and the deep learning model, including the modified transformer model, are employed to predict the target variable based on the pre-processed user input. And the 13th one is final outcome as displayed. The predicted result, which could be classified as a spam or not spam, is displayed to the user, allowing them to gain the insight and make informed decisions based on the model prediction. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder which contains of different files within it. The dataset folder contains of the testing and training dataset, and the static folder contains of the CSS file within it, and the template file contains of the HTML documents as of home and result, and it is an Jupyter source file where contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it easier for the students or anyone. And the app is an py file, likely contains the information related to the front-end logic. It includes the code that is written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. For the execution of the project, first we need to copy this address path and open the Anaconda prompt, and we need to change the disk position because our code folder is present in the app disk. That's why I'm changing by using the command, and here the disk is changed, and here we need to write a command of cd space and paste this address and click on enter button. After this we need to write another command of python space app.py. This command is executed on the Anaconda prompt to execute the Python script and perform the runtime check for any syntax errors and logical issues, and click on enter button. After running this app.py file, the Flask framework will host the application locally at the default address as of like this. And we need to copy this local link provided by the framework and paste it on any web browser. And I prefer to use of Chrome, and opening the Chrome and pasting this link and click on enter button. Here we get an home screen like this. Here we need to enter the SMS. In this dialog box I am entering the SMS as free entry in a 2-weekly competition to win FA Cup final tickets of 21st May 2023. The test FA 287121 to receive the entry question. This is an SMS, and let's check it's a spam or not, and click on let's check button, and here the result is a spam message. In this way we can detect the spam or not by using this deep learning and the machine learning algorithms. And finally, the project's conclusion highlights the superiority of the proposed and modified transformer model over the machine learning classifier and the state-of-the-art spam detection approaches. Through the extensive evolution of the SMS spam collection dataset, and the proposed model consistently outperformed its counterparts. Particularly on the SMS spam collection dataset, the proposed model achieved the exceptional result in terms of accuracy, recall, and FN score, surpassing the performance of the alternative classifiers. These findings showcase the potential of the proposed model to effectively tackle the SMS spam detection challenges. Moreover, we discussed the future research direction to enhance the proposed model further. These include scaling the model to the larger dataset, exploring the more complex transformer-based architecture, and leveraging the advanced technique for data pre-processing and feature extraction. These insights not only validate the effectiveness of the proposed model, but also lay the foundation for the future advancement in the SMS spam detection methodologies.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.